Hi everyone, David Maley here, and today we're going to go over 3D spinning scatter plots again, but we're going to do them a little bit more advanced or have some more colors and techniques and different things we're going to do with them. So what I want to show you today, let me just show you what we're going to end up with in the end here. We're going to end up with a graph like this and some other ones like this. Let me make this bigger for you here, which is really cool. So I want you to be able to create some really cool things like this. Alright, so what I want to show you, I've got the code right behind this, but first I want to tell you we already have another video that does 3D scatter plots, and a YouTuber named Adrian Soto asked me a question, and the thing was that scatter plot was only in black and had it to several attributes, but it was no color differentiation. And he was asking, is it possible to have different colors for each of the attributes? Yes, it is. Here's one here, but I'm going to show you more in depth with this. So let's go in here and let's go over this right here. So first we'd have to bring in these libraries right here. So you see these three libraries here: RGL, ReadXL, and then this bottom one I have it highlighted just in case you have it in a different location. Some people, you may have to put the specific location for it to get it to work correctly. I don't, but it depends on the version of R that you're using, the RStudio that you're using. Okay, so once you've done this, if you don't have them, use the install packages to put it inside here, bring it in, and then run the libraries. Once you've done that, then we're going to read in the data. So this data set is the Bikeshare data from the University of California, Irving's Data Science Department. So you can get it there. This is how you bring it in. So you would hit Control and Enter here. This brings in, puts in this vector called test data 3, which is data frame. If we want to see it, we go over here. It's called test data 3. So I click on this and give it a second. There it is. And here's the data. It has these columns: instant, day to day, season, year, month, holiday, weekday. The ones we're mainly looking at is count way over here. That is the number of total people that rented these bikes. They also have casual and registered. So casual would be new ones, registered would be returning people, returning customers. You also have temperature. You have we're also going to be looking at month and or season. I'm sorry, season. So see, you have seasons 1, 2, 3, and 4. And I'll show you that in here. So if we go back here, now that we have that, this is what I left you with in the other video. So let's show you this. Okay, it shows you all the data, and it shows it to you by the let's bring this, well, let's actually close this. Let me show you what it does. It brings in 3 fields. So you got 3 columns. You've got your X column, which is the first one, right? So we've got this right here. This is your Y column. And to get 3D, you have to have a Z column. This is your Z column. So we have count, which is the sales or the rentals, the total rentals. We have temperature, and then we have season. And we're using a function called plot 3D. Okay? Plot 3D is out of the RGL library right here. If you don't put this in, you will not be able to run plot 3D. So when we run this with the X, Y, and Z, we get this. Now we can make this bigger so you can see it better. And it's got small dots, but it has it broken out by seasons. Remember that? That's what we're doing, by seasons. So there's 4 seasons, 1, 2, 3, and 4. And you can see the difference in sales between the seasons, but it's kind of hard to see because they're black and white, and they don't really, I mean, you can see maybe here from this angle, you could see, a little bit of variance in it, but what we really wanted to be able to do is see it better with colors. So let's take this, let's close this. Now look at the next one. Next one is right here. We've got the same thing, plot 3D, but the only thing is I changed the size, right? So I've got this, the rest is the same, so I added a little attribute right here called size, comma, size equals 5. Let's see what that does. So now see how the dots are bigger? Let's bring this down here so you can see it better. And grab it here. So the dots are a little bit bigger. We can see a little bit better. But see, when you transpose them on each other, even at an angle, it's kind of hard to tell and differentiate between them, right? So we need to be able to see different colors between the different seasons. I want different colors for the seasons. So now the next one, you can see the little notes above here too. The next one, what I've done is I've added this little, I've taken the one above, I got rid of the size, but I'm adding color, col equals test data 3 seasons. So I'm coloring by the seasons. So I should have 4 different colors, right? You would think. So let's take that one right here, and let's run that. We got 4 colors, but there's one problem. It's what you're going to find is the red happens again after you get to 4. So see that? So if I put the red over the red, you can't tell between the reds, but at least you have the blue and the green, so you can kind of see those, and you can see the difference between them a little bit better. Okay, that's one way to do it. Now I have another one if I want to do rainbow colors. So I can bring this color equals rainbow, and I can pick any different color number of combinations here for the rainbows. So the lower the number, the more different colors it brings in for all of your plot points. And it can make it look pretty, but it can make it look annoying too. So let's do this. I've got 849 as my number. Let's see what that does. See that? Now that one looks, as you have a higher number like that, it does fewer color combinations in there. So you'll see how it has blue and red down here, light blue and red. The middle one here has a couple different colors, and it's almost like clustering. And this one, but it's not. And this one has green and blue, and this one has a light green. This one has a darker green, and you can see very well how they, show between the different seasons, which is kind of neat. I like the rainbow like that. Now, if I were to go and change that from 849 to, let's say, I don't know, 100. Let's do that. Let's see what that does here. See how I told you when you use a lower number, it brings in a lot more colors to it, and it will make it kind of a little bit messy. I mean, if you like a lot of colors, and it looks kind of cool that way, I guess. But it's not really useful for laying on top of each other. So you need to have a higher number, like the 849 or even 1,000 maybe. Let's see what 1,000 looks like. Here we go. Slightly different color combinations there. That's kind of neat because you can see it laying on top of each other. Now, the next column here, or the next set of line of code here, tells you how to make better labels. So the ones before, if you look at them, let's just do it again. Okay, look at your labels are the actual name of the different fields with the data frame. So you have the data frames test data 3, $, and then count, or whatever it is. It's a little bit messy to have it that way. So instead, if you look at this line of code right here, underneath it, right there, let's bring this over. We have at the end xlab, ylab, and zlab, and then equals something in quotation marks. I could put anything. I could put sales instead of count if I wanted to. I could put temperature. I could put weather. I could put seasons, whatever I want in there. So let's run that. Got the same chart as I did when it had 849, but now let's open it up. Let's open it up again so you can see. You see this now? Now it just says count, temperature, and season. That's a lot prettier, a lot better than this big long data frame with all that stuff with the $sign written on it. Okay? Makes it better. Then, now we're talking about multicolored. So if I took the rainbow and took it down, remember I took it down to 100? Watch this. This right here is, I've got one of the original ones, right? With the 3 X, Y, Z. And then I have column or color equals 1 through 50. Now watch what this does. See that? It's got a lot of points, and if you just want something that's colorful, this is the way to go. But when you lay it on top of each other, it's very tough to differentiate between which is which. And if I were to, I can do the same thing as I did up there, and I can increase it or decrease it. I could say 1 in 1,000 or 1 to 1,000. Let's see what that does. Here we go. See how it gets messier? So this does the reverse. The other one is it goes lower when you do this column equals or color equals rainbow. The lower you go, the more colors it gets. This one, the higher you go, the more colors you get. So if I bring this down, get that little area there. There we go. See all the colors in that? It becomes quite messy when you lay it on top of each other. There's no way to differentiate which is which. But if you use a low number, let's say I use 10. Let's see what that does. This one still is a mess. We would have to get down to like 4 or something like that. Which then will probably get us close to one of the originals. No, still messy. But what we're going to do is let's go down here. So let's take that back to like 100 or something like that. And if we go to the merged attributes, okay, so this is where it gets kind of cool. So you saw a graph with X, Y, and Z coordinates, right? So if I take the same one as one of these with 849, so if I were to take this one, take it back to 849, so remember this? Okay, and let me show you this. This is with X, Y, and Z in it. Okay, that's what it looks like. And you can clearly see the 4 seasons in there, right? Especially if I put it sideways like that. You can see them 1, 2, 3, 4, right? Now, what happens if I take away the Z, right? What's going to happen without Z in there? So let's go here, merged attributes, this one. So if you see, this is a little bit shorter because I took out the test data 3 season, $ season right out of there. And so we've got test data 3 count, temperature, and the color equals rainbow 849. Now look at that. So without the Z, it takes the spring and summer and fall and winter and kind of like merges them together. So you can see you have your 4 seasons still, right? But they kind of flow. See that? So it depends on what you're trying to do with it. If you're trying to get them to flow back through the different seasons, that kind of shows you better as to when the start and the end of each of the seasons are. So it depends on what you're trying to do. But this is kind of a cool way to look at your data. And then because you have these colors, unique colors to each season, right? When you fold this over, you can see where they lie. Versus if they're all the same color or there's too many different colors in there, then you can't tell. Next, I want to show you something really cool. So now we're going to do spheres. So you were doing dots, right? If I do this again, I'll show you. This is what we're looking at when you bring it up big. These are just dots. So remember that cool graph I showed you at the beginning? That was actually spheres. This is not spheres. These are dots. So the next one is a little bit longer code. Okay, plot 3D. These are all with the plot 3D function. Okay, but what we're going to do is this part's the same as what we've done before with the X, Y, Z. But now we're adding this piece down here where it says type equals S, color as numeric, and we're coloring the season by the season, right? The season field test data 3 $ season. And then I've only added this little bit at the end, which is just like up there to give us better labels. So if I take this, where type equals S, and remember column as dot numeric, test data 3 $ season. If we do that, let's see what that does. Now look at that. That's the spheres, okay? So if I bring that up, we can rotate that and you can clearly see. Now the only problem with spheres is you have no see-through ability. So you can't lay it and superimpose it, but you can see really well, very clearly when you show it sideways here as to what is in which season. Now the problem is though, you can't really see from the season begin to the end and then go back to the others. You can't, it doesn't flow. So if I were to take this, and remember we did before, we took out the Z, right? So if we do that here, plot 3D, test data 3 count, test data 3 temp, but we don't have the test data 3 season, which is Z, type S. If we do this, watch what happens. We get a really cool looking graph that when we bring it up big, now we have a flow through. So we can see which is in which column, or which is in which season, and that's just pretty cool. So if we look here, there's our seasons, right? And we can see how, you know, a better representation of it. And it doesn't have to be seasons. This could be anything. You could look at I don't know, weekdays. Like if you have a business that's open Monday through Friday, you could have Monday, Tuesday, Wednesday, Thursday, Friday. You could even have Saturday. You could have, Monday through Saturday that your business is open, and you could show each day of the week as to the sales or customer orders or wholesale orders or whatever. If you're business to business or anything you want, you can show it, and it's just a great way to be able to represent it. And then you can take snapshots of this and say, look, we have, some of this Tuesdays flows into Wednesdays. You can do all kinds of cool stuff. It's a great way to represent your data. It's really neat. So again, here we showed you here multiple graphs. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9 different ways to show your data here. You can start off with the typical simple one, which is this. And the problem with this is, as I said before, you've got your seasons, but it's just kind of hard to represent it. So you might want bigger dots. You might want some colors added to it. So that's why we went through this and show you, the different sizing options here, right? The color options that you can color it by your attributes. So this is what Adrian Soto was asking right here. So if I do this, there it is right there. Now the problem with this color function is on its own it only knows 4 colors and keeps repeating them. So if I, no matter what I do, it's going to be blue, green, blue, or red, green, blue, red here. But that's fine for what we're doing. If I want to show it in spheres, which might be cooler, I just have to go down here, and I can also show it in multiple colors like we did. So if I want spheres, remember, I just go down here. It's the exact same thing. And there it is. And then just bring it up bigger. And that might look cooler. The only difference is you can't see through because the spheres are thick and they're not, see-through. So, or they're not transparent. But you can see the difference between the seasons clearly, which is kind of neat. That's what this is for. So the 3D Scatterplot is a way to be able to visualize your data, and then you can take a snapshot of this. You can put it into a dashboard. You can put it into a report and document the breakdown of the data, whatever it is. It could be stores. I could be right here comparing 4 different stores. How is sales in these stores better, worse? Instead of seasons, I could be comparing different products. I could have some new products that have just launched by a company that I'm working at or for, and I could be comparing them. Here's the old products, 2 old products, here's 2 new products. It could be anything. In this case, it's Bikeshare data from the University of California at Irving, and let me show you the data if we didn't show it to you earlier. I show this in many of our other videos. This is a pretty common test data set. And it's just basically Bikeshare data. I think I showed this to you earlier. And you have temperature, humidity. I mean, I could show you anything in here. Just keep in mind when you're using attributes, you want something that's going to have not more than maybe 6. If you have something that's got 100 attributes in it, it's going to be a mess. It's not going to look good in this, because if I took, like, for instance, wind speed, I would have to break it down into, like, 5 miles an hour, 10 miles an hour, 15 miles an hour, 20 miles, something like that. So I've got like 6 or 8 different groupings. That's what you want. You don't want to have too many. I've got 4 in this, as you can clearly see when I plot these, because obviously there's 4 seasons. But you can clearly tell if I had like 20 of these in here, this would be, in this box, it would be very messy. I'd have to blow this box up really big to get them all, and it would be very messy. There's just not enough space in there. This is something for graphing, like 4 stores, 6 stores, 4 to 6 products, something like that. Seasons, weekdays, because weekdays you'd have 6 or 5 depending on how many days you're busy, or 7 if you're open 7 days a week. Things like that. You could also compare different shifts if you wanted to. If this was in a warehouse, this is in operations, you could compare, shift 1, shift 2, and shift 3. And some people have like 4 shifts because they overlap. So it depends. Anyway, this is how you do make some great graphs like this. I showed you all the code. Have fun with it. If you need the data set, go to University of California, Irving, Data Science Department, look it up. Bikeshare data set. It's very easy to find, download. It's not a huge data set, and it's pretty cool to work with. It's 2 years of Bikeshare data. But anyway, have fun with this. Thanks for watching. I hope you found this helpful. Please subscribe, like, and comment, and have a great day. Thanks.